begin with Noah Snavely. Noah is an assistant professor at Cornell University. He's also working at Google right now. As I mentioned this morning, the work that got many of us excited was his phototourism work, which was part of his PhD thesis. He's gone on to do many, many great things, and we're all looking forward to hearing what he has to say today. So, Noah.
Thank you. Thank you so much. Thank you so much, Michael, and thanks everybody for being here. You know, it's such an incredible honor to be standing here today, and you know, it's wonderful to see all of you. Thank you for coming to the talks. So today I'm going to be talking about a theme I've been excited about for a while now, a theme here I'm calling planet scale visual understanding. And this is the idea of using all the world's photos to come up with some kind of deeper insights and understanding about the world around us, how it's changing, what's going on in the world, and so on. And so part of the motivation behind this is that, you know, I don't have to tell you, you've probably heard all sorts of statistics bandied about how many photos are uploaded every day to the web, how many photos are shared on Facebook, et cetera. But I found, you know, we're definitely in the, no matter how you slice it, in the age of big visual data. So one statistic I found, it captured my imagination, is the folks at 1000memories.com, you know, they do archiving of photos, crunched the numbers and figured that every 2 minutes, quote, today we capture as many photos as the whole of humanity took in the 1800s. So maybe that's surprising to you, maybe it's not. But it really captures, I think, the essence of the world we live in, this world of massive visual data. And of course, all this data is being shared and, you know, uploaded to the web. So it's really the case that the internet has become this living visual record of our world, with every event, every city, every person, you know, captured many, many times and shared with everybody. So one question is, can we do anything useful with all this data? So is it all fun pictures of cats, or is there something deeper? Is there something more meaty we could sink our teeth into with all of these images and derive a deeper understanding of what's actually happening? And you could imagine, you know, just thinking about it, all the sorts of things you could do. You could build the ultimate 3D model of the world. You could, you know, view the world from any viewpoint. You could use this maybe as a tool, you know, a new kind of scientific instrument, where you could analyze changes in environments over time, study patterns of traffic and human behavior. Is that, you know, you could imagine all of this is revealed through these collectively through these large photo collections. Maybe you could find surprising events, anomalies that are infrequent. Maybe you could more generally use this as a question answering machine. All these photos go through a meat grinder, and then you can just use it to answer questions, forensics. You know, what happened? Why a bridge collapsed? What led up to that? Wouldn't it be amazing if you could do all these things? And so there's some very interesting precedents for this idea in other fields. One that I'm particularly inspired by is astronomy, where this is the work of Sam Roeis and a group of astronomers. They developed this tool called astrometry.net, where you can take your amateur astronomy photo that you've uploaded to Flickr, and it will automatically tell which part of the night sky you're looking at. So it automatically registers it with the night sky, and will give you tags and show, okay, you were looking at the Horsehead Nebula. All automatic if you upload it to this astrometry.net Flickr group. And then these astronomers took the next logical step, which is, okay, now that we can estimate these poses of all these amateur astronomy photos, can we do science with it? Can we make observations with these images? And they showed, yeah, they set themselves to this task of tracking this particular comet, its trajectory, and they showed that just using these crowdsourced photos, they could make these observations. And that doesn't mean they're going to like run out tomorrow and throw out their $100 million instrument in favor of photos that appear on the web, but it's an intriguing idea, it's an intriguing application, and you know, astrometry is often at the forefront of these new kinds of citizen science ideas. But can you take these from this idea from the night sky and, you know, look at something closer to home? So there's this other work in the last couple of years that I'm also very inspired by. This is the work of a group at Indiana, including my friend Dave Crandall, where they took Flickr photos and tried to estimate snow cover in the United States automatically for a particular period of time from these images by doing things like looking at the tags on the photos, doing visual analysis. Is this geotagged photo, does it contain snow or not? And they were able to say, okay, yes, we can produce a reasonable estimate of snow cover just from these geotagged photos. But this is still very coarse, like at the level of 1 degree latitude, longitude, is there snow on the ground in this square in the United States? These kind of applications that I'm thinking about, these world-scale visual analysis would require much more fine-grained understanding at the level of individual cars that you track and collectively build up understanding of from many, many photos. And of course, the challenge here is that all this visual data is extremely large, massive image collections, billions of photos a day, and it's also fundamentally unstructured. These photos aren't systematically geotagged, time-stamped. You don't know what's in the photo. That's a very difficult image understanding computer vision task. And so how do you start to build the tools that will enable these kinds of new applications, scientific and otherwise, from these photo collections? And so you can sort of think about it and break it down into a few different key challenges that, different axes of the problem. One is place. So here's a photo. You might want to, this photo tells a story about Central Park. There were trees that were turning red and so on. In order to understand that, you first have to know what part of the world you're imaging. So what's the camera frustum of this particular image? In order to relate that to an actual measurement, you have to know also what time the photo is taken. And then there's a task of what story is the photo telling? There's trees in here, they're a certain color, and then you can imagine once you can estimate that from a single photo, you can start correlating those measurements over time. This particular tree in Central Park, what did it look like on August 1st, August 2nd, all from these crowdsourced images. Also you can look in the sky, see what in a very fine-grained way, what the weather was at this location at this time. So image understanding is another key part of this. And then I'll throw in another one, materials. So these three that I've talked about pertain a lot to outdoor scenes, but I've been interested recently, very intrigued by the idea of indoor image exploration, indoor exploration of visual data. And with my colleague Kavita Bala and Shambel and other students, we've been looking at this problem. So I'll sort of use these 4 different coordinates as the framework for talking about some of my work and some other work that I'm inspired by in computer graphics and vision. So the first is place. So, you can take any famous place and do a Flickr search. You'll find tens or hundreds or millions of photos, hundreds of thousands of photos. And from this unstructured set, it's very difficult to get a sense of what happened in the scene over time. It's hard. There's no framework for organizing these images. And so to start to build that framework, you have to understand place. And so when I was a grad student with my advisors, Steve Seitz and Rick Slisky, we started thinking about this problem of how do you organize these photos in a more structured way. And we developed some tools that can take these very unstructured photos, like these images of the Colosseum, and automatically using computer vision techniques we devised based on the long history of work in geometry and vision, tools for automatically recovering geometry. So photos in, algorithm, and then what you get out is where all of the photos were taken. So the black triangles you see in this image are camera viewpoints for Flickr photos. You see the 3D point cloud, the sort of ghostly version of the Colosseum in this image. All this automatically estimated from these unstructured photos, something that hadn't been done before, taking unstructured, very messy data like this and extracting this much more structured representation. And then we took that a step further and used this structure to build new kinds of ways of navigating photo collection. So here's another reconstruction. This is, I think, the first one that actually worked well when I was reconstructing different scenes. This is sort of the aha moment that we could reconstruct the Trevi Fountain from these internet photos. But here, okay, we've clicked on the photo. This is an interactive interface where we zoomed into that photo, but we can do a lot of other interesting things. We can select a region of the image, like this central statue, and then because the system knows where all the photos were taken, it has this underlying organizational principle. It can figure out what is the best photo of that object, automatically use the geometry to morph to that view, and then suggest other viewpoints. You can do other nice things like zoom in and out. It's putting geometry, adding geometry to the mix is a very powerful way of anchoring all these photos together. So we later put all this code for reconstruction online, and it turned out that being able to reconstruct geometry from unstructured photos is a pretty useful thing. And there's a number of computer vision and computer graphics research that has used this. Also, beyond graphics and vision, I've had ecologists talk to me about this tool, archaeologists using this for their domain as well, again, as a very sort of useful building block for structuring photos. This is also used as the basis. Rick Slisky was one of my co-advisors for for a tool that Microsoft developed called Photosynth, where you could take your own personal photos and build a 3D model that you could then explore. And over time, they've augmented this with more sophisticated features, depth maps, image-based rendering techniques that give a compelling sense of place. Whoops. So we later took that in another direction of adding structure to the scene in using the idea of reasoning about how people move through these places, using where people take photos, another kind of crowdsourcing, to then design new camera paths through these scenes. So this is a image-based rendering type visualization of the Pantheon, where you can click on different images, and it will use knowledge of where other people have taken photos to guide you on a nice path. You're not going through the walls of the place. You're walking where others have tread before to give you this nice sense of visualization, how all these photos fit together and how they connect in natural ways to navigate between them. We've also done a lot of work on scaling this up. So this is one of my favorite point clouds we've created. This is the old town of Dubrovnik from many thousands of photos. Again, so there's a lot of computer vision horsepower powering this that we need to scale up, and the result is on these many thousands of photos a very nice point cloud reconstruction where again you see where everybody took their photo of the old city of Dubrovnik. So we've come a long way in being able to reconstruct geometry from just arbitrary photos that we scrape from the web. Another direction we've taken this is in connecting this geometry to other sources of knowledge about the world. So here's a photo. This is Times Square. This is a place I'm obsessed with reconstructing because it's so cool. So here's a photo of Times Square. We have a reconstruction of it. This reconstruction is not just floating in the world. We can actually pin it down to the actual location of Times Square, and then we can connect it to all the other knowledge about Times Square that's out there in the world. So this is work with my student Kevin Matson that we published at ICCV last year. So for instance, New York City released as open source all of the polygons describing all of the roads and sidewalks and medians in the city of New York. And if you know where the photo was taken through this geometric analysis, you can just project that into the photo, and now all of a sudden you have for free a labeling of all of the roads and blue in this case, sidewalks in green, and medians in red, and just by having this geometry to connect you to other sources of data about the world. Here's another example where we're rendering, there's 3D models of the world. We're rendering that atop the image. And this is, in this work, we are also very inspired by previous work in computer graphics from Microsoft Research and others, this work called Deep Photo, where they use 3D models like this to enhance images. Okay, so again, we have a pretty good understanding of place and geometry from photos. It's physics. You can write equations down to describe how photos relate to one another. How about time? How do we start to reason about time? So, of course, part of what makes the world interesting is that places aren't static. They're changing all the time. It would be pretty boring to live in a world that's the same every day. Like Times Square is one of my favorite examples of this. You can think of different time scales at which Times Square is changing. Like every minute, cars are whizzing by, people are milling on the streets. Every month there's new billboards going up advertising new products and Broadway shows. Over the course of years, buildings are shuttered, new businesses open. It's a very lively and dynamic and interesting, rich place because of this temporal dimension. Another place I really like, there was this, I guess you could call it a graffiti mecca called 5 Points in Queens, where if you're a street artist, you could go in with your graffiti and without fear of being arrested, spray paint art on the walls over what was there before. So it's this rich art history of paintings one atop the other and of evolving, living art gallery. So it'd be very interesting if you could build recover the history of these kinds of scenes from internet photos. There's this very cool work by Cassidy Curtis, who some of you might know. He's a member of the graphics community. He has a site called Graffiti Archaeology, where he lovingly and painstakingly took photos of these places over time and then manually created these experiences where you can view these places at different slices in time. But that's very manual. Maybe we could do this automatically from all the data that's out there in the world. So how do we capture these kinds of changes beyond the sort of rote 3D geometry we've reconstructed? There's some nice work by the folks at Georgia Tech, Frank Delaert and his students, on a project called 40 Cities, where they try to do this at the scale of centuries using historical photos of a city to try and reconstruct the history of the buildings in that city. So this is a work of Kevin that we'll have appearing at ECCV this year, where we try to do a similar goal, but much more granular. Can we reconstruct, for instance, Times Square, what it looked like every day for years from these internet photo collections? And so we have this paper, Synchronology, where we first reconstruct the scene as one big single 3D reconstruction, sort of the union of the scene across all time. So every point that was ever in Times Square is reconstructed, and here's sort of iconic corner you're seeing on the screen here. That part that looks like it has the Phantom of the Opera billboard actually has lots of other billboards mushed together because there's lots of things that were advertised there. Although maybe Phantom's the longest one because it's a long-running Broadway play. Anyhow, so we took this. The key challenge was to sort of take this mush and extract out all the different time layers, and we came up with a clustering technique to do this, where now we have all the points in this 3D point cloud that belong together clustered into the same spatiotemporal object. And then we can do cool things like, for this particular region of this world, this bounding box, this white bounding box, this piece of real estate, we can sort of create an exploded view across time of what that billboard was advertised. In this case, it's Broadway shows across time that we're using this space. We can also create new visualizations. Here's the 5 Points place. We've reconstructed it. This is a 4D visualization where we're flying around in 3D, but also playing through time. So you can see all of the different pieces of art that existed inside 5 Points at the time when it existed. So it's this interesting 4D view of this location. Okay, so time, it's a little less fleshed out, but we're starting to get a handle of that. How about materials? So materials really comes into, I think, becomes an interesting thing in its own right, especially if you're talking about indoor scenes. So if you think about the spaces we inhabit, your home, a lot of the look and feel is determined by the materials that are in that space. But if you want to sort of reason about materials in a large-scale way using all this data, you can't really use the same 3D modeling tools I've described so far, because you can't just, I wouldn't want it to be the case that I could download tens of thousands of photos of my living room from Flickr. That's just not going to happen. So what we do instead is we use another means to extract structure from large photo collections. This is work with Kavita Bala and Sean Bell and other students at Cornell, where we used crowdsourcing to annotate these images. So people in Mechanical Turk were asked to label and annotate material regions in photos like the one I just showed you. And we created this huge open database called Open Surfaces of labeled annotated materials and images. So we have tens of thousands of segmentations for any kind of material you want. Wood's a good example. Again, many of these are lovingly segmented by people on Mechanical Turk who like to do segmentation. This is reminiscent of the Label Me project, but more specifically targeted towards materials. Plus, we get all sorts of other information. We have people label BRDFs. We have people label surface normals. It's this very richly annotated set of data that's ripe for visual exploration. So we also explored some applications of this along the lines of material exploration, where, for instance, you can do a query by material type. Show me other kitchens that have a similar hardwood floor to this one. You can answer that kind of query with this data we've created. Or show me living rooms which have a similar fabric sofa to the one in this image. So this is sort of just the first step. There's many other powerful applications you can enable with this kind of data, this kind of rich material data. We have another paper here at SIGGRAPH this year called Intrinsic Images on the Wild, where we take this material data and further segment it using intrinsic images into material and lighting labels, again using annotations we derived from crowdsourcing. So large-scale visual exploration of materials, again, enabled by large-scale crowdsourcing. Okay, so this is the part I know the least about, understanding. So this is sort of the least fleshed out of this part of this talk. But the idea here, again, is returning this idea of visual understanding of the world from crowdsourced photos. And the idea that every photo tells a story. So you see a photo online, it's not just some fantasy world, right? It's a photo of something that actually happened. It's an event. In this case, maybe you'd think it's sort of a boring event, like, yeah, there's taxis driving down Manhattan, big whoop. And maybe this one photo in itself isn't revealing interesting stuff about the world, but then you think about, okay, what if we could tell the place and time? What if we could exactly geolocate this photo? So it's not just 3 cars, but we know exactly what part of the street they're driving down and what time they were driving down it. And then, maybe you could get the license plate and then track individual taxis across town and start to build up the secret routes of taxi drivers in New York City. And it becomes more interesting if you then take this idea to the billions of observations from the individual photos uploaded. So you could spend the story told by these billions of photos is a rich description of the motions of cars and people through New York City. Here's another example of maybe not so interesting looking photo, but it tells a story. There's a woman with a yellow scarf. Maybe that's not so interesting in itself, but if you started seeing people with yellow scarves all over the world, all of a sudden you could then reason, okay, maybe there's some new fashion statement that's happening. Maybe I'm observing a new trend. Maybe yellow is the color of the season. So I think, again, once you start thinking about photos at large scale, these things become very interesting. And so, but in order to do this, we have to have a computer that understands about yellow scarves and people and cars. Requires a deep understanding the story these photos are telling us. Requires a deeper understanding, and that's where I'm excited by recent work in computer vision. Vision has made a lot of progress, but recently things have been there's been a breakthrough of sorts in deep learning, and certain problems that are traditionally very hard, face recognition, human pose estimation in images, object detection, are starting to become, I would say, good enough where we're ready in the graphics community for this kind of large-scale visual discovery. You could start to use these tools in the vision literature and trust them enough that you could robustly start to estimate these things from images. So I've thrown a lot at you. I'd like to just end by stepping back a second, and I did this earlier, but I want to just reiterate how thankful I am to the people who have mentored me in the last 10 years in the graphics community, especially my advisors, Steve Seitz and Rick Seliski, who are just wonderful people and mentors. My undergrad advisors, Greg Andrews and Shomya Debray. My first SIGGRAPH was actually right after undergrad, SIGGRAPH 2003. I was doing compiler stuff with Greg and Somya, and it gave me a great taste of research, but it's very low-level stuff. And I was introduced to this world of SIGGRAPH, and it was really a bright lights, big city kind of moment where my eyes were open to this very exciting and vibrant community. And I really have to thank the community and for this being a great community and this level of excitement. I published a paper with Li Zhang as the first author. Here's an image. It sort of looks like this comedy tragedy mask. This is a figure from the paper. Is actually on face animation and scanning. And this was really another eye-opening experience, like the first SIGGRAPH. It was almost a hellish experience where many late nights, all-nighters, staying in the basement coding. But working with Lee on this really gave me good insights into the SIGGRAPH process. I also want to thank all my colleagues at Cornell University, and I'll give a shout out again to Kavita, who's just been a great mentor and just has a superhuman ability to, even though there's lots of stuff going on in her life, to sit down and help you with stuff. I spent a lot of time at UW in the Grail Lab and with folks at Microsoft Research and other collaborators I really have to thank for making all this work possible. And again, it's really their award. And finally, all the great students that I've been so fortunate to work with at Cornell. So just maybe some words. I don't really have words of wisdom, but the one thing that I feel like I've learned is that you should find ways to work with great people, because that will enable success. And also I found that for me personally, it's important to find roles that force you to learn a lot. And it's okay to feel like I've learned to have no idea what you're doing, because you'll probably learn how to do it, especially if there's great people helping you along the way. So finally, thank you to my wife, Beth, who's here in the audience today, and the rest of my family for all of their support. And thank you to the community. Thanks so much.